Okay, good evening everybody. So welcome back to part 2 of Euclidean geometry, proportionality theorem. So that is, if you are still with us even now, that means you are liking our videos. You are actually enjoying the lesson of this proportionality theorem. Please make sure that you leave your name on the comment section so that I can properly thank you for watching our videos. So let's go back to our corollaries. Yes, previously we have proven that AB over BD, it is equals to AC over CE. We have we have worked with the proof as is. We spoke about the area of triangle ABC. We spoke about area of triangle BCD, and yes, we have shown that these two areas can be worked out as a ratio. So then they give us AB over BD. Same applies to the area of triangle BCE, ABC and BCE there. So now also they can be somehow written as what? As a ratio there. But now we had a helper definition, the definition that helped us to actually equate these two ratios to be proportion. So we know by helper definition that area of triangle BCD and area of triangle BCE, they are equal. Why they are equal? Because these two triangles, they lie between parallel lines and they share the same base and height there. So now we're gonna go to the corollaries of this theorem. So now let's say we had something like this. Let's say we want to find AD over, let's say, AB. AD over AB there. Also, what? Let's say AE over AC there. So this is what? This is I have AD over what? AD over AB, which is equivalent to what? Which is equivalent to AE over how much? Over AC there. So that's AD over AB equivalent to AE over AC. So that's our first corollary of this theorem, corollary number 1. So number 2, let us check number 2. So I will just rub this off like so. So let's check number 2 there. Let us use the purple one. So we see that dB over what? Over dB over BA is equivalent to how much? EC over what? Over CA. So it's gonna be dB dB over I have BA, sorry, which is equivalent to what? Which is equivalent to EC over what? over CA there, over CA there, over CA there. So that's corollary number 2. So let us check corollary number 3. So for corollary number 3, we will have, let me just rub this off. For corollary number 3, we will have, let me check, we will have DA over how much? Over BA. Equivalent to how much? Equivalent to EA over how much? Over CA there. So now this will be DA over how much? Over BA there. Equivalent to how much? Equivalent to EA over CA there. So that's our corollaries there. You may continue and maybe investigate if we have more corollaries in proportionality theorem. You are more than welcome to actually investigate more corollaries, but for today I'm gonna leave it here. So find out more corollaries on this theorem. So I hope this theorem is clear to everyone, and yes, we will go straight to the applications of this theorem. It is very nice to work with this theorem. Let us see the first example, the application, which is named as important example 3. So they say to determine the value of k and respective lengths using the below constraints. Okay, so now you are given that if NP is parallel to, let us mark that one. They say to you NP, it is parallel to what? It is parallel to LM there. Okay, and also you are given that Kn is to NL, it is equals to K plus 1 is to 3, and Kp is to Pm is equals to 4 is to K. So now the first step, you will say, our solution will be like this. You will say set Kn is to NL to be equivalent to K plus 1 over how much? Over 3. Also, Kp is to Pm to be equivalent to 4 over K. So it is clear that Kn will take K plus 1, okay, and NL will take 3. What about Kp? Kp we have 4, then Pm we have K. Okay, so now if we proceed with this question, we will say this implies that Kn over NL, it is equals to Kp over Pm. Why am I saying that? We're gonna say Kn over NL, it is equivalent to Kp over Pm. This is proportionality theorem. So how are you gonna reason? You're gonna say line parallel to one side of our triangle there. Line parallel to one side of our triangle there. That's your reason when you are applying proportionality theorem. So line parallel to one side of a triangle there. So now this is true if and only if what is Kn? It's K plus 1 over what is NL? That's just 3. What is Kp? It's 4 over what? Over K there. This is true if and only if you cross multiply. We have K into K plus 1 equivalent to 4 times 3, which is 12. So we will further go with this. We multiply K times K. We have K squared, K times 1 there. So we will have K squared plus K equivalent to 12. Then we can somehow take this 12 that side. Let me write it like so. We will have minus 12 equivalent to 0 there. Alright, so remember, in Euclidean geometry we expect results, so we will use factorization here to actually find our factors. Okay, so now this implies that K plus 4 and we have K minus 3 equivalent to 0. So now proceeding with this, we will have K equivalent to minus 4 or K equivalent to 3. So it is clear that K minus 4 is not our solution, because our values of K must be element of what? Of real numbers which are positive there. So we need to have real numbers which are positive there. We are not looking for negative numbers there. So now we're gonna say, therefore our solution will be K is equals to 3, because K is an element of real numbers where K it is not negative. So that's our solution there. We have K. So remember that you must provide good and full detailed solution when it comes to Euclidean geometry. We expect full detailed solution when you're dealing with Euclidean geometry. Remember, Euclidean geometry, it is the art of what? The art of reasoning. We need to test your reasoning skills. So make sure that you have your reasoning skills sharp at all times when working with Euclidean geometry. So now let us go to another example. Important example what? Important example 5 there. Okay, so I think this one is nicer because we have more triangles. So now in the figure below, PV is equals to 24 centimeters and VR is equals to 22 centimeters and ST is equals to 12 centimeters. We are also given that PQ is parallel to VS and PS is parallel to VT. Now we want to calculate the length of what? The length of QR there. So we want to calculate the length of QR there. So now I'm gonna start by filling in my sketch. So PV is 24. So I'm gonna have my 24 here. 24 centimeters. Then my VR, it's 22 centimeters. And we are given that ST is just 12 centimeters. It is further given that PQ, it's parallel to what? It's parallel to VS then. PQ is parallel to VS. Then also it is given that PS, it is parallel to VT there. So what I'm doing now, we call it sketch analysis. We are analyzing our sketch. Okay, we are taking the information that is given and filling in our sketch there. Yes, so now moving forward to our solution. Let me think on how we're gonna answer this one. Sorry about that. So now I'm gonna start by answering this like so. Solution. Let us start with triangle PRS there. So I'm gonna say, sorry, consider triangle PSR. Now, since PS is parallel to VT as given, then PV over VR it is equals to how much? ST over TR. So let me quickly write my reason and we will go back to our sketch and actually look at what is happening. We will look at what is happening. So line parallel to one side of our triangle there. Now let us go back. So where is our PV? We see that PV over what? Over VR, it is equivalent to how much? It is equivalent to ST over TR there, because you see that triangle PSR, it has two parallel lines, PS and V at VT there. So PS and VT there. Now we can use our proportionality theorem there and say PV over VR, it is equals to how much? ST over TR there. And our reason will be line parallel to one side of triangle there. Now we will proceed. This implies that 24 over 22, it is equivalent to how much? It is equivalent to 12 over TR there. Now for us to find TR, we will cross multiply. So this is true if and only if 24 times TR, we have 24 TR there, and also 22 times 12 there. So now for you to proceed with this, you will divide both sides by 24. We will divide both sides by 24. So now what is TR? Therefore TR will be equivalent to 22 times 12 divided by 24. It's 11 centimeters there. So we have 11 centimeters there. Let me just confirm with my calculator. So 22 times 12 divided by 24. Yes, I get 11. So we have 11 centimeters there. Now we have TR. We have what? We have TR, because our aim it is to find the length QR there. So now we see that TR, it is contained in QR. So we need to find the length of what? The length of TR there, so that we can somehow find the length of QR. So now let us go back. Let us go to our solution again. Sorry. So now, as we have found TR, we will consider triangle PQR there. So we know that since PQ is parallel to VS as given, then what is it that we know? We will have PR over VR equivalent to QR over SR there. Now your reason will be line parallel to one line parallel to one side triangle there. So let us go back to our sketch there and check. So we said what? We said PR. So let me just remove this ones. Let me just remove this ones. Okay, so about that, we will have 22 there. Yeah, so this is 22. So PR, let us check. Where's our PR? PR over what? Over VR. You remember our corollaries. So PR over VR. So whatever you have done here on this side, on the upper side, you will have to do it on your downside or lower side. So now let us check. We will say QR because we have started with PR that side. So we need to do what? We need to say QR over what? Over SR. So whatever we do on that side, we need to do on this side for those two ratios to be in the same proportion. All right. So that's just a corollary of theorem 1 there. So now we will proceed. Sorry, let me just put an extra page there. Sorry about that. Yes. So now we have our extra page. So now if we proceed with this one, we will say, what is PR? Let us check PR. Let us check PR. So PR will be 24 plus 22, which is equivalent to 46. So we will have 46 over, what is VR? VR is 22. So over 22, which is equivalent to how much? QR, the one that you are looking for. What about SR? What about SR? What about SR? You remember SR. We have found TR first so that we can find SR. So now we have ST. What is ST? Guys, what is ST? So ST is 12. So that's 12 plus TR. What is TR? TR is 11. So 12 plus what? Plus that 11, we get 23 for that one. So we have 23 for SR. So this is true if and only if what? We cross multiply now. QR times 22. We have QR times 22 equivalent to 46 times 23. 46 times 23. So this implies that QR, we divide both sides by 22. So that's 46 times 23 divided by 22. So therefore, your QR will be equivalent to what? We will say 46 times 23 divided by 22, which is about 48,091 centimeters. I prefer 3 decimal place. So 48,091 centimeters there. So this is our QR there. So that's how you can find the length of QR using a proportionality theorem. So make sure that you understand this question and make sure that you redo this question, you rewrite these solutions in your own handwriting. So remember, as I've said yesterday, that understanding comes from doing. So if you don't do these questions, you'll never understand them. So now let us go to important example 6. So important example 6, yes, it involves more triangles again, and yes, it's nicer. So now let us check. We are given in the figure below that PQRS is a parallelogram and we also see that QS is parallel to BC and QB is to BR. It is equivalent to 2:3. Now we want to calculate PO is to OC. Let us think about this one. So please make sure that you pause a video and try to do it on your own. When you are done, please play back the video so that you can see where you went wrong. So I hope everyone tried this question, and yes, let us see how we solve this question. We will start by sketch analysis first. All right, so now let us start with the sketch analysis. So now it is given that your PQRS is a parallelogram. So what do we mean by that? If this is a parallelogram, that means PS will be parallel to what? Will be parallel to QR there. Okay, then what about PQ? You know that PQ, it's parallel to SR. Also, it is given that QS, it is given that QS, it's parallel to BC then. QS is parallel to BC then. So what I'm doing here, we call it sketch analysis. Please make sure that before you answer your question, you do your sketch analysis. It is extremely important. I can't emphasize this enough, more than I'll already have, that the sketch analysis, it's very important. So now what is QB is to BR, which is 2:3. So now we will give QB, QB corresponds with 2, so I'm gonna give it 2K. What about BR? I'm gonna give it what? 3K there. So now let us solve this question. So our solution will go like this. So solution, consider triangle what? Triangle OQR. Do you have an idea what are we gonna do with triangle OQR? Let us check. Where's triangle OQR? So OQR. So let me highlight that. It's OQR there. So this is that. Okay. So now I'm gonna go to say that since QS it's parallel to BC, then QB over BR, it is equivalent to OC over how much? Over CR there. Okay, so now let us check that one. So from the sketch we see that QB over BR is equivalent to OC over what? Over CR there. So that's our proportionality theorem. So when we reason, we're gonna say line parallel one side of our triangle there. So remember, you need to reason with prescribed reasoning. Please check your mathematics, the latest examination guideline. There's those prescribed reasonings for Euclidean geometry. So now this implies that QB over BR, it is equivalent to what is OC in terms of ratios. No, what is QB over BR, sorry, in terms of ratios, it will be 2K because QB is 2K over what is CR, it's 3K. And we can both agree that this ratio, it is in same proportion with OC over CR, according to the above question there. Now, let us be smart. Now, let's set, since that we see that QB and BR are in the same proportion with OC over CR, we can somehow set OC is to what? Is to CR, meaning OC over CR to be equivalent to 2Q is to 3Q for Q element of real numbers where Q it is not negative. Now, why are we doing this? Because we know that QB and BR are in the same proportion. So meaning, of course, OC and CR will have a proportion of 2 over 3. But we need to give this a different letter, not K. We can choose any letter, Q, S, whatever we can choose. But I prefer Q for this matter. So now, it is given that OR, from our sketch, OR, it is equivalent to OP. OR equivalent to OP. But why is that the case? Let us check our sketch. OR, what is OR? OR, let me just do this here. OR, this is our OR. Let me just highlight that OR. OR, it is equivalent to OP. It is equivalent to what? To OP there. OR equivalent to OP. Why is that the case? It is the case because these are diagonals of what? Diagonals of parallelogram. That's our diagonals of a parallelogram. So now please make sure that you use your detective skills when solving Euclidean geometric questions. Make sure that you invoke your detective skills. You make sure that no stone is left unturned. Make sure that you do what? You use your detective skills. So we see that OR is equals to OP because they are diagonals and they are equal. So now we can say a PO, it is equivalent to OC plus CR. Let us check PO. Where is PO? PO, yes, PO, it is equals to what? OC plus what? Plus CR there, because we know that PO it is equals to OR, but OR it is the same as OC plus CR. So now we basically said that PO is equals to OC plus CR then. Now PO will be equals to what is OC? We see that OC is 2Q. What is CR? CR is 3Q. So now we have 5Q here. For Q, element of real numbers, where Q, it is non-negative. Now let us say this implies that PO is to OC with PO. Let us check our sketch. PO, let me just grab here off. So now let us introduce the new information. We said PO over OC will be what? PO over OC. PO over OC will be, what is PO? We see that PO is 5Q. But what is OC? What is OC? What is OC, guys? What is OC? Let us check OC now. Remember we said QB there, okay? So QB corresponds with what? With OC. BR corresponds with CR. So now OC will be 2Q as given there. OC will be what? Will be 2Q there. So now therefore PO is to OC will be equivalent to 5:3 there. So now when you want to write this, you'll say PO over OC is equals to 5/3 over 2, sorry, over 2, that's 2, sorry, that's 2, 5/2 there, 5/2 there. So now that's how you solve PO over what? Over OC there. That's how you solve PO over OC. Kappa PO is to OC there. So now I hope it is clear. So PO is to OC is equals to 5:2 as required. So please make sure that you rewrite this example in your own handwriting. You redo this example in your own handwriting and you write this solution. And please remember that understanding comes from doing. So when you don't do it, you won't understand it. Please get your hands dirty. So let us move on to another example. So we move on. Oh, now it's a theorem. Okay, let us move on to this theorem 1.2 there. We call it what? A midpoint theorem. We call it midpoint theorem. So the midpoint theorem is a nice theorem. I think you have came across this theorem in grade 10. So yeah, let us revise this theorem, midpoint theorem. So case 1, they say that if AD it is equals to DB. Now let us check that one. So they say if AD it is equivalent to DB, and what? And AE equivalent to EC. Then what is it that we know? We know that DE it's parallel to BC. So now if AD is equals to DB and AE is equals to EC, then this implies that DE is parallel to BC there. And what? And let me break this for you. So we have 2DE, which is equivalent to what? To BC. So meaning DE it is equals to half BC. So this means that, so DE is equals to what? DE it's half BC. That means BC is twice DE and DE is half of what? Of BC there. All right. So now please appreciate this theorem, and the proof of this theorem, it exists, but we won't prove it now. It is out of the scope of this context, so we can just appreciate the theorem as is. So now for case 2, we will say if AD it is equivalent to DB and what? And DE it's parallel to BC. Then this implies that AE it is equals to EC there. And again 2DE equivalent to BC Therefore, what is DE? DE, it's half BC there. That means DE, it's half of what? BC, and BC is twice DE. So make sure that you understand these two cases. These two cases are extremely important for the following example. So they're very important in the following example there. So now let us check this example. Important example 7. So hopefully this is our last example for this part 2 video. Now this example is tricky, so please make sure that you pause the video and try this example and confirm your answers after writing. So I hope you have attempted the important example 7. So now let us check how we can solve it. So I think there is a typo on our worksheet. Let us check. Bullet 2, CD parallel to AC. It must be, sorry, there's a typo. It must be CD parallel to FE, not AC. CD parallel to FE there. So I apologize for that typo. It must be CD parallel to FE there. Now it is given that ABCD is a parallelogram and CD is parallel to FE, and PC is twice AC and DQ is twice AD. Now we need to show that E is the midpoint of AD. Now we will start with our sketch analysis. So what is it that we know? We know that ABCD is a parallelogram. Now this guy is parallel to that guy, this one is parallel to that one, also this one parallel to that one, this one parallel to that one there. Okay, now we also know that FE, it's parallel to what? It's parallel to CD there. So yeah, FE is parallel to CD there. That's what we know. Now we need to show that E is the midpoint of what? Of AD there. So now we need to show that this point is actually a midpoint of what? Of AD there. But for this to be true, according to midpoint theorem, AE must be equivalent to ED exactly, for E to be what? To be a midpoint. So now how are we gonna solve this question? We will solve this question like so. We will say let me do this. We will say number 1, AF is equals to CF. Where is AF? AF is equals to CF. What is that? We will that's our diagonals of parallelogram, because it is given that ABCD is a parallelogram, so that means AF it is equals to CF there. That our diagonals. But we also know that FE it is parallel to CD there. FE is parallel to CD there. That's given. That one is just given. We know that one. It is given. Okay. So now if this, because according to our case we said that if AF it is equals to FC, and what? And FE it is equals to CD. That means AE it is equals to ED. It is our second case there. We said if AD is equals to DE and DE is parallel to BC, therefore AE it is equals to EC there. So that means this number one, it needs what? The application of the case 2 there of the midpoint theorem. So now we can conclude and say, we can say what? Then AE it is equals to how much? ED. Our reason will be midpoint theorem. Midpoint theorem there. Therefore, the conclusion will be say that we'll say therefore E is the midpoint of AD as required. So now that's how you solve number one. Let us check number two. Let us check number two now. So number two, prove that PQ is parallel to FE. We need to, let me do this. We need to prove that PQ, let's check with PQ. We need to prove that PQ it is parallel to FE. So we need to prove that. So now let us do that. Let us do that. So I'll say set PC to be equivalent to 2AC. This you are given, okay? They said to you that PC is equals to twice AC. So you're given that. So but this implies that PC over AC will be equals to 1 over 2. Because if you divide both sides by AC, I wanted to say, sorry, I made a mistake here. Let us start from here. So if you divide both sides by AC, you'll have PC divided by AC, which is equivalent to what? 2. Okay, that's equivalent to how much? To 2 there. So this is our, let's say this is our A, and we have another one that is given. They said to us that DQ it is twice AD. So I'm gonna say DQ twice AD implies we'll have, therefore I divide both sides by how much? By AD to have DQ over AD, which is equivalent to 2. So now let us name this B. So from A and B, from A and B, it follows that PC over AC it is equals to DQ over AD, which is equivalent to 2. Here we have what? same proportion. They're in the same proportion. So they're in the same proportion now. They're in the same proportion. So we see that. Let me just highlight what we have found there. We said PC over AC. So PC over, let's say CA, it's fine. CA, it is equivalent to DQ by QD over how much? AD there, by DA. So now we see that this AC over CP and AD over DQ, or PC over CA, QD over DA are in the same proportion. All right. So if they're in the same proportion, the theorem have stated that if these are in the same proportion, then we will say this will be parallel to that. All right. This is just a reverse of proportionality theorem. This is just a reverse of proportionality theorem. So I'm gonna say, then if the above is true, then we know that CD is parallel to PQ. Then those will be just the converse of proportionality theorem. This is just the converse of proportionality theorem. But now we see that CD, it's parallel to what? It's parallel to FE. That one we know. We know that CD, it's parallel to what? It's parallel to FE there. It is known that CD is parallel to FE. So now if CD is parallel to FE, this means what? This means that PQ is parallel to FE. Why? Because they are both PQ and FE are parallel to CD. So both PQ and FE are parallel to what? To CD. Hence we say that PQ is parallel to FE also. So guys, I hope you have enjoyed this video and you've learned a lot from the examples that we have done. So this is just an application of proportionality theorem. So this theorem, it is extremely important. So now please make sure that you appreciate the context of what? The content of this theorem, and you are able to prove the theorem for the examination purposes, and that you understand the midpoint theorem, and you also understand how to apply all the contents you have learned from proportionality theorem. So thank you so much for joining this session. See you on the next one.